All right, so today we're taking a look at two variable inequalities. Before we were looking at grade 10, you probably did maybe one. So you might have had something like, x is less than 3, and you did this and you went, okay, well, if this is like 0, 1, 2, 3, you would have done something like this and said it's less than 3 and sound familiar? I'm not asking you to like it. Sound familiar? Sort of? Okay. So today we're going to look at what happens when we use two. That's the rest of this unit actually, is what happens when we use two inequalities. Or sorry, two variables in the inequality. So to give you an idea what I mean here, if I plug in 2 and 5 like this, what do you think? 2 and 5, can anybody tell me where you might have seen something like 2 and 5? In that, written that way? Think of your graphs. Yeah, it's a point. So what do you think is x and what do you think is y? That's right. So that's what we're going to do here is we're going to use x and y. It's just a short way of writing it down. So that's x and y, and I'm going to put it into my inequalities here and see if it's true or not. So in the first one, so let's say that's number 1, I'm going to put in 5 less than 2 times 2 plus 5. So I've put this 5 in for y and this 2 in where there was an x. So if I then check to see is this true, it is. So that inequality would work for that point 2, 5. Okay, so that's what I want you guys to try for those other three. We'll see which ones are part of those inequalities and which ones won't work for those inequalities. Okay? Okay, so let's just see if we got that. Oh, that's a terrible color. Hang on. Mustard, yeah. So what about the second one? What do you think? Does this work in the second case? Hands up if you think it works for the second one. Well, if you're not sure, the quickest way to do it is to try it. So it'll be 2 plus 3 times 5 minus 1. Is that greater than 0? So that'll be 17 minus 1 is 16. So yeah, in fact, that is greater than 0. So that works as well. Okay, how about the next one? Okay. Geez, do these all work? Did I make them too easy? So 6 minus 5, is that less than 8? Yep, that one is also going to work. Okay, so that'll be 6 plus 5. Is that greater than or equal to 11? It is in fact equal, so it's okay. So all four of them work. Because I put 3 times 2 here, plus 5. So that's where the plus sign comes up. So what if you only have the same inequality? And this is what we're going to work with more so today, is just a single inequality. And we wanted to know which points here are a solution to that inequality, like which ones work. So what we're going to be doing is testing each one against it. Same way you did before, but we're using the same inequality. Okay, so what do you think? Doesn't work this time. So that one definitely is not a solution. Okay. Does the next one work? Okay, so we have 2 times 7 minus 3 times 0. Is it greater than or equal to 5? Yeah. Okay, yeah, sorry. It'll still work out, but you're right. It should be 2 bracket 3. Okay, so greater than or equal to 5. Yep, so this one will work. Yeah, greater or equal to 5. Okay. So what about the next one? Doesn't work? How come? Yeah, it's going to be negative, so we can eliminate that one. And the last one? You sure? Well, I wouldn't go making up rules and shortcuts about whether they're positive and negative. You definitely want to actually put the numbers in. You're right, they're both going to be added. Yeah, that's what you're going to get a bigger number when you add them. You get 4 plus 6, so 10. 10 is bigger than 5, and yes, this one works. Okay. Now, the thing is, though, we don't want to have to go through this all the time. So how do we show all the possible answers that we could do without having to, list all these points out? That's what we're going to talk about today. So the way we can do that is with a sketch. How many people got the graphing paper I asked about? Oh, good. Okay, so a couple. What's that? I don't know if the Post-its are around. Did anyone find Post-its? And you found them? So anyways, again, a reminder, this unit is going to be very helpful to you in your homework and whatnot to have graphing paper. Please stop squeaking that. It's okay. It's just, it hurts my ears. I know. It's we got to fix that. So let's go back to where we were yesterday. All I'm going to do when we sketch this is we're actually going to show it with a line and the boundary for where things are less than or equal to it. So here, the steps we're going to do is graph the line. So in this example, the line that I'm talking about is this one. You ignore the fact that there's an inequality and you just say, let's look at this line. Okay? But there's one extra piece of information that we have here. So let me show you what this means. If you see the equals sign, like in this one right here, that means you can include everything on that line. So you draw a big, thick, solid line. Whereas this one does not let you be equal. So we can't actually touch that line because that line is everywhere that it is equal. So to show that it's not actually the line itself, we draw a dashed line saying it's everything that's, one side of this, but it doesn't touch the line. So let's go back to drawing this line. For example, if you remember from last day, it'll be at -1. And this one's going to go 5 over and 3 down. Okay, and then 5 over, 3 down. And I can go backwards, 5 over, 3, like that. I have to tell you, I've never felt the pressure to draw straight lines like I have with this class. So well, there's a bump in the middle, but otherwise. So, what did I do wrong? Oh, that's right. So just remind yourself when you do this, if there's no equal sign and it is not equal, you cannot draw a solid line. You want to show that it's not equal by doing this. And that actually makes my line a little easier to draw. So that's step number 1. The next thing we have to do is test a point. So I'll show you what I mean by this. When I do this inequalities with students, I tell them this is like the border. This is a map. We've just put a border in, and now you got to do the citizenship test. You got to find out which side of the line you belong on. Okay? So you can pick any point you want, but it's going to tell us which part of this, is it the top or the bottom half of this map that we belong on. So somebody give me the coordinates for a point. Any point you want. 2 and which? 7. I just heard 2 and 3 first, so I'm going to use that one. Okay, so here's my test point, 2 and 3. What I want to do is find out if 2 and 3 belongs, and the way I do that is I put it in my inequality. So I want to know, is 3 less than -3 over 5 times 2 minus 1. Anything you want, although I'm going to show you in this case there's better points to pick than, some points make life easier than others. Okay? I'll give you a strategy in a second. But that means is 3 less than, and this is like, well, it's going to be a negative number, but I'll write it down for you as negative 11 out of 5. Is 3 less than negative 11 over 5? Well, one's positive, one's negative, so which one do you think is bigger? 3 should be bigger, right? So is that true? 3 less than negative 5 over 11, or negative 11 over 5? No, it's not true, which means you failed the citizenship test. Guess where you get to go? The other side. You go back to the other side. If you pass, you stay where you are. So because I know that this one doesn't work, that means this is the answers that I'm looking for. Any point on this side will satisfy that inequality. So I don't have to list every single one. I just shade it in to show you that this is the side. Any point you pick in here will work. So let me show you a little strategy. What made this bad to deal with? Why does this not look, what happened that was ugly about this? The fraction, right? We don't like fractions. Can anyone think of a strategy that would help us avoid that? What's that? Make it a whole number. How do we make that fraction turn into a whole number, though? Yeah, times it by the denominator. So if I was, instead of picking 2, if I was to pick 5, then that number would disappear. It would make things a little easier. So let me show you. If I was to pick, it doesn't have to be positive 5. I could pick negative 5 too. So why don't I pick this point here in purple? And I'm going to, that is the point, negative 5, negative 3. You can pick any point you want, but again, the reason why this works better is when I plug it in this time, I'm going to ask is negative 3 less than 3 over 5 times negative 1 minus 1. Sorry, negative 5 minus 1. So when I do this, that fraction is going to cancel out, and I'm going to have negative 3 less than 3 minus 1. Is negative 3 less than 2? Yes, it is. Every point in that side will end up working in the inequality. Remember, you don't need to check everyone. You only need to find out the one time. So what we're going to do is, we're not going to go through such a detailed explanation this time. It's really not as scary as it might look by having spent 5 minutes on it. But I'm going to do this next one for you, in probably the fashion you'll be used to doing it for your homework. So once we've tested the point, we shade the side where they're a citizen. It's supposed to be a quote, yeah. Okay, so let me just give you a minute in case you're copying things in there. Yes. So the first thing we do is we need to graph the line. And before we start, we need to know, is it solid or dashed? Solid. It is solid. How come? There's an equals there. So let's draw a solid line. I can go down to negative 2, and I'm going to go 1 up, 2 over. 1 up, 2 over. Okay, so here's, and I normally, like I said, I never draw this many dots, but you guys are got me all paranoid now. Okay, so there's my line. Step number 1's done. That's what we were practicing for review. If you got to hang on it, that's fairly straightforward. What's the second thing we need to do now? Test a point. So somebody give me a point. 4 works nice. What other points work nice if I use x equals 4? What else would work nice? 3 doesn't really work that nice. How come 3 isn't that nice? 2 and 4, what else works nice? 8. 6 would work nice. We're trying to get rid of that fraction, right? So it's not that you're wrong to shout out those numbers. It's just that we can get rid of the fraction if you pick an even number. So let's pick that point at 2 and 1. Okay. Can anybody think of a ridiculously easy number to test?
0.
Why? You remember how we talked about the first time we graphed lines, how I said zeros make the laziest number because it knocks things out? Well, watch what happens if I was to pick 0 for my points. So, whoops. So 0 as my point, okay? You can pick any point you want, but I'm trying to make life easier for you. If I pick 0, watch what happens. X and y are gone because they're both zeros. So now I'm left with that inequality. It's pretty quick. Is 0 greater than or equal to -2? Yeah, 0 is bigger than -2. It's like you might not have anything in your bank account, but if somebody owes $2, then they have less money than you. So this is the side that we shade in because that's where it passed its citizenship test. Okay? And in general, if I have to give you advice, that's the point I would like you to use just to make life easier. It's going to work, I'm going to guess 99% of times 0, 0 is going to work. But why do you think it might not work sometimes? If the line goes through 0, 0, you can't take the citizenship test on the border. You can't stand on the Canadian and American border and say, which side do I, or, you know, you can't say, do I belong here? I don't know who belongs on the line because you got to pick a side. So that's the only time it won't work is if the line goes through 0, 0. That doesn't tell you which side they're supposed to be on. All right, so this one here, how do you want to graph this line? You want to rearrange it, or how do you want to do this? So let me just see, hands up, who wants to rearrange it? Okay, who wants me to do the thing where we put zeros in and we solve for the intercepts?
Oh, that's fun too.
Okay, well, we'll do rearrange. That seemed to be most popular. So if I rearrange it, remember what I'm working with is 2x minus 3y equals 12. I'm looking for the line. So I forget about the inequality. And then I'll have negative 3y equals negative 2x plus 12. Yeah, we'll divide by 3. So I'm going to have y equals 2/3 x minus 4. We have to divide it by -3, that's why, yeah. So that gives me a line to graph, so I'm going to drop down to here, and it says move over 3 and up 2, over 3, up 2. Okay, and I'm just going to wing it this time. I don't know if it's going to turn out as well, but. Oh, good, thank you. That's okay. So now that I have my line, what am I going to do? Test a point. So can we use 0, 0 here and be the ultimate of lazy? Good. There it is. So if I put in 0 minus 0 greater than 12, I want to know, is 0 greater than 12? So you get kicked over to the other side, and this is where you end up. Okay, the next one is yours to try. Work it out with the neighbor. Make sure you agree. We'll walk through it in a minute. So here we go. First thing I'm going to do is pretend I'm dealing with 5x plus 3y equals 9. So the equation is 3y equals, yeah, you're ahead of me. 3y equals negative 5x plus 9. Then if I divide by 3, this is my line. Okay? Is this going to be a solid or dashed line? Solid line, because the equals is in that equation, so it's solid. So plus 3, and I'm going to go 3 over and 5 down. 3 over and then 5 down. Okay. So it'll be something like this. Oh, that was awful. Good enough. All right. So now that I have this, I have to do what? Pick a point. Can we pick the easy point? 0, 0 works nice because it's not on the line. So if I plug that in, 0 plus 0, is that less than or equal to 9? So since it worked, that's what we're going to shade in. All our answers are over there. Okay, so that is really all we're going to practice today, but sometimes you're going to find that when we do the answers in some of the problems, we're not working with all possible numbers. So we have to do a quick review. I'm not sure if you saw this in grade 8, 9, or 10. It depends where, how far back or what year it was you took the math, because everything just shuffled. But how many people have heard of things like rational, irrational, that kind of stuff? Okay. So just as a review, rational, do you remember what a rational number is? Sorry? It could, right? So one thing, it could be a repeating decimal. The other, if you're thinking about it as decimals, it's repeating or terminal. But yeah, the key thing in a rational number is it can be a fraction. Some numbers cannot be expressed as a fraction. They're not rational. Numbers like pi. So irrational numbers, pi is an irrational. The square root of 2, there's lots of irrational numbers. In fact, there's an infinite amount of them. As strange and weird as they are, there's loads of them. So within the rational numbers, the numbers that can be expressed as fractions, we have the integers. And what the integers look like are the negatives. Yeah, 0. And then they keep going. Yeah, for whole numbers, we're going 0, 1, 2, 3, and on and on. And the natural numbers are 1, 2, 3, and on and on. Altogether, we call that the real numbers. So all of those numbers fit within the reals, and there's some really good abbreviations if you're using these in your word problems. The real numbers has a big capital R like that. Sorry? Yeah, second line. But yeah, question? Can there be fake numbers? Well, they don't call them fake, but they call them imaginary numbers. Yeah. Okay, let me pause it. If we're gonna get a short sidetrack here, I won't put this on the YouTube video. But yeah, let's. Okay, so the other shortcuts we have here are integers. You can use capital I in your homework. Whole numbers, you can use capital W, and natural numbers, you can use capital N. Win, yeah. So here's how I was taught, and I think it's a pretty good way to remember what the natural numbers and whole numbers, like sometimes it gets confusing. The natural numbers are the ones that you first learn when you learn to count. You don't find many kindergartens that when you ask them to count that they go 0, 1, 2, 3, right? They usually start by going 1, 2, 3. So the most natural set of numbers that you learned were the ones that started at 1 and were whole numbers counting up. Okay? The whole numbers allow you to talk about 0 as well. So sometimes you're in your problems, you're allowed to have 0. Integers, then we're adding negatives to it. Rational means any fraction. And then if we keep going beyond that, we're talking about the real number set. So, yeah. Just a second. Just a second. No, let me just show you what this says, okay? All this is a lazy math notation. This says, these brackets mean a set. I'm showing it to you for a couple of reasons. Number one, the notation is something you need to know from your learning outcomes. Number two, when you open your textbook, you're going to see the notation. But all it means is those brackets mean the set. The first thing up until this vertical bar means of points x and y. And these are all the conditions that it has to follow. So it's not just any numbers x and y. It has to be numbers x and y so that this is true and that x and y are part of the whole numbers. So really, when you do this, you're going to ignore all that fancy notation. You need to focus right here and start by saying, okay, my first thing I have to do is make sure y is less than 3x minus 2. So forget about the notation. I want you to try graphing that and shading the proper side. Okay, what is y less than 3x minus 2? All right, so it sounds like we're ready to move. Let's make sure here that we're just working on this one inequality. So I go -2, and it goes 1 over 3 up. Maybe I'll do another point here just to give myself an idea. And is this a solid or a dashed line? Good, so oops. So it's roughly going to look like this. Now, we can still use our favorite point because it's not on there. So I can stick in a 0. And if I go, is 0 less than, I'll change the color so it shows up better. Is 0 less than -2? No, it's not. So we're going to be on the other side. We're going to be over here. It's not bad. It just means we color the other side because we guessed wrong. So that's the solution I drew so far, and that would be the answer if that was all the constraints that I had. But this says x has to be a whole number and y has to be a whole number. So the way we convey that is in the problem then I'm going to go like this and just say you can only use the whole numbers. So it's not actually the shaded area, it's just these dots here. Okay? So now what I'm going to say for our class is that well, I would pick better graphing paper than to make myself shade in 100 points. But I'll say that if there's ever a situation where there's more than, why don't we agree that 6 points is reasonable? That as long as you have 6 points drawn into your graph, I'll know that you mean to do everything in there, okay? So, you know, for now, let's just do a few more here. We'll spread them out just so we can see that, you know, it's all the way along here. But if x and y are whole numbers, it's not actually those black lines. It's only going to be these whole numbered points like this. So that's enough. Hopefully you get the point here that again, so what I'm saying is I'll pick a better graph. I'm not expecting you to spend half an hour coloring in 100 dots. So we'll all agree that you'll show me at least 6 and I'll know that you mean to shade the rest of them in. Okay? Whole numbers include zeros. So the reason why is eventually in this unit, we're going to have problems where we want to represent the answer, and it might be like the number of, I don't know, iPods and the number of cell phones, and you can't have half an iPod. So the answers would not be every possible number. It would only be the whole numbered ones. We can have 0 iPods, but we could not have 1.5 iPods. Okay? Question, yeah? No, the whole... Oh, sorry, thank you, yeah. That's what you were trying to ask. Yes, so 0 is included, but the negatives aren't. Yeah, so basically it would be there. So it would just be this section there with the dots. Okay? So, oops. So that means we're going to need to adjust our little agreement a little bit. Just so that I know you didn't forget, I'm going to need you to just shade the area, but just put your 6 dots in there so that I know you mean my shading is only on the dots. Okay? So we'll do that again in the next example. Just shade the area where it's all the dots are, and then draw just a few dots so I know that you're talking about only the integers in the next case. Okay, so I'm going to walk through the next one with you again because I know this notation looks really scary, but let's forget about that notation. All we're focused on is to show this set of points, we need to work on these constraints. So the first constraint that you're going to want to work with is that one right there. So I'll leave you guys to start plotting that, and then I'll catch up to you. 3x minus 2y greater than or equal to 6. What'll that look like? Okay, I'm gonna go on the board here. I can see, can I get a couple of shushers? Thank you. You can go back to your discussion. I can see you guys are talking about what your answers were there, but I'm going to put mine up here too. So if you could just tone the volume down a little so we can follow along, but feel free to keep looking over your work with a neighbor. So I would end up with this equation for my line. And I would go 1, 2 over and 1, 2, 3 up. And it's a solid line. And then I'm going to test my favorite point, which is 0, 0. So is 0 greater than or equal to 6? Because those would both be gone. So no, that's not true. So since it's not true, it's going to be this side of the line that I'm allowed on.
It's not negative.
No, yeah, it's 6. That was the equal sign underneath it, yeah. So the area that we're looking at then, the only other thing we haven't dealt with are the integers. So what does it mean if x and y have to be integers? Give me some examples. -1, 0, 2. It could not be something like a fraction though. So basically we're saying it's this black area I shaded in. So I'll make this is the area I'm looking for. But then just so Mr. Joyce knows you don't mean all of them, we're going to pick a few points just to show that we mean it's only on these whole numbers like this. Okay, so you just have to give me an idea that I know you mean the answer's in there and it's only the dots. Okay, so this one I would like you to try. This last one, can I move it down? This last one, I'd like you to give it a try by yourself. These are only the natural numbers count in this one. Okay, so I'll show you what my solution is going to be here. Okay, so this one says that there's my line, and if I test the point 0, 0, which I'm certainly allowed to do, is 0 and 0, those would be gone. So is 0 less than or equal to 3? Yes, it is. So this is the side that I'm going to be concerned about. But remember, that's not, yeah, it's only the natural numbers. So that means it cannot touch 0. So it could not be any of these points over here. None of these will work. It's only a very select group. Yeah, it can be on the border because there's only that one point that's going to, work here. It couldn't be this point because that way y is 0 and y is not allowed to be 0. It couldn't be over here because x is equal to 0. So there's actually only one answer out of all the possible ones we have. That's the only one that fits all those criteria. You just color the dot like I did. You just fill in the dot. That's it. One dot, that's all we have. Yeah, so that was only part of my rough work, right? My rough work, that would be the answer, that black dot. Okay, so last one. I'm going to assume that we're probably okay with the lines now, so I'll do the line with you to speed it up, and then you guys do the shading. So 2x plus y minus 5 is 0. Okay, so there's the part I think most of you guys are probably okay with. I want you guys to work on the shading. There's your constraints in there. Let's finish this off then, gang. This one says we need to test a point, so my favorite one is available. So 0 plus 0 minus 5, is that greater than 0? Well, -5 is not greater than 0, so it's going to be on the other side. So if it's going to be somewhere on the other side, you can just do this for your rough work and then say it has to be real numbers. A good question was brought up. Remember, the rational numbers are actually a Q because the rational numbers are like a quotient, and that's got a Q for its symbol. So it's saying any real numbers that are on this side of the line. So my solution would look shaded in the whole thing like this. Yeah, so we could use any number set, but this one is for reals. Yeah.
So basically, if we have a real number, like a rational number, or it's real anywhere.
If we had a Well, rational, if you did come across a rational, it wouldn't be able to go anywhere, but there's so many rationals that it would look shaded in. There would be holes in it. It would be like your t-shirt, right? Your t-shirt looks solid, but there's holes all throughout it. That's the way the rational numbers would look if you drew it. So it's not possible really anyway. Okay, so last thing we want to do is take a look at this problem here. It says a sports store. We're almost there, gang. We're almost there. A sports store has a net revenue of $100 on every pair of downhill skis and $120 on every snowboard. The manager's goal is to have revenue of more than $600 a day from the sale of these two items. What combinations will meet this goal? Well, it says more than 60 though. Okay? So let me just show you one of the tricks when you're dealing with word problems, right, is to translate what you have. So it says revenue is $100 for every ski and $120 for every snowboard. So revenue equals 100 times, I guess we'll use, yeah, snowboard though. We'll use B for board, I guess. It looks like 100 seconds. There shouldn't, that's just an S. It's not a, God, you guys are so judgmental. So 100 for every ski plus 120 for every snowboard. And it tells us that the manager wants to make sure that we make more than $600 a day. So what I'm going to do then is take those two pieces of information and combine them. So what they would say is, the manager is saying, I need there to be 600 has got to be greater, 100 times the number of skis we sell plus 120 times the number of snowboards has to be greater than the $600. Well, in this case, it says more than $600, so we would just say greater because they want more than 600. Now, what kind of numbers do you think we're dealing with in this solution? Well, not necessarily the magnitude of them, but what kind? Whole numbers? Okay. What about integers? Yeah, we can't use negative skis or negative snowboards, but we could use whole numbers. What about like natural? Should we exclude? Is it possible that we... you can sell 0 snowboards. Okay, so I think we're in agreement then that the skis have to be part of the whole numbers, and that the snowboards have to be a part of the whole numbers as well. So even though we haven't written it the same way, those things that we just came up with are the, we want to know what are the possible answers when, oops, sorry, and for us it's S and B. We'd want to know what's the possible answers for 100S plus 120B to be greater than 600, and so all I'm saying is, you know, the notation doesn't look that friendly, but that we've just done the same thing there, okay? Now, can anybody think of a strategy here to maybe help us do some graphing? What's that? Sure, we can move one of them to the other side. That'd be fine. So yeah, if we... well, I'm going to show you the other way that we had talked about it, right? What happens if I go like this and I have snowboards and skis? Yeah, so if I put a 0, what would happen if I wanted them to be equal to 600? How many skis would I have to sell? 6 skis. And how many boards would I have to sell? So I can use the axes here for, say, boards and skis. So it'll be So it'll be 5 boards and 6 skis. And it has to be greater than that line there, so it would have to be dashed. So think about it for a second. Visualize this in your head. Does it make sense to try answers like down here? So what does that tell you about where the answer is going to be? The other side. So we could go and test a point, but it should, there should be some intuitive sense to you that this is where I'm looking, and that I'm looking at all the whole number solutions here. So I can't actually go down here. This is a mistake, not this. It's also a mistake to go over here. It is only this line along there. So we can only look in this area, and it's only going to be the whole numbers. So again, if you had some nice graph paper, we could show just a bunch so I know you mean just the number, the whole numbers that are there. Okay? So don't sweat the word problems too much. That's something that we're going to spend some time on. But for today, I want you to be able to show your solutions on the graphs. So this was the questions on page 303. We will talk about it in tutorial next week as well. So you should get some start on it and maybe possibly look at it over the weekend. But Monday we will revisit this as well, okay?